Hey everybody, this is chapter 7, section 1. In this section, we are going to find greatest common factors for a set of terms. We're going to factor polynomials by finding the greatest common monomial factor, and we're also going to factor polynomials by grouping. All right, so I've sent the PowerPoint to you that I'm using, and it's got the directions. So basically, we're going to try to find what is the biggest number or sets of variables that we can divide three terms by. So your very first problem on your paper should say the numbers 30, 45, and 75. All right, so I'm just going to think of the factors of each number. So starting with 30, what numbers can multiply to give me 30? Well, I know that 1 times 30 is 30. I know that 2 times 15 is 30. I know that 3 times 10 is 30. And I know that 5 times 6 is 30. And that's all of them. So once you get to the middle, if I continue going up, I would get to 10. Well, 10 is already written. So I know I have all of the factors of 30. All right, let's now do 45. So what two numbers multiply together give me 45? Well, 1 and 45, 3 and 15, and then 5 and 9. And that's all of them. Now 75, 1 and 75, 2 doesn't go into 75, 3 does, 25, 3, 4, nope, 5, yes, 5 times what, 15? Yes. And that is, I think we got them all, right? 2 times 25, 5 times 15, yep. All right, so basically you want to see, okay, what is the biggest number in each of these groups of numbers? Well, I see common 3s, but that's not the biggest number. I see common 5s, that's not the biggest number, but I see a common 15. So in other words, 30, 45, and 75 could all be divided by 15. That makes 15 the greatest common factor of these numbers. So I did this problem a little differently earlier, but to me, I think the example that I just showed you was the best way. I did the common factors, the prime factorization, but if you can see them all written, you can see what's the greatest common factor, what's the biggest number I can divide them all by. All right, so 15 is it for 30, 45, and 75. All right, so I'm going to do the next example like this. I'm going to rewrite this. So 20x to the 4th y, 15x to the 3rd y, and 10x to the 5th y squared. All right, so what are the factors of 20? Well, we know 1 times 20. We know 2 times 10. Is 3 a factor? No. Is 4 a factor? Yes. 4 times 5. And I've made it to the middle, and I know I've got them all. All right, for 15, I know it's 1 times 15 and 3 times 5. And that's all. And then 10, we have 1 times 10 and then 2 times 5. And that's all. So what is the biggest number that you see that they all have in common? Well, of course, you know that's 5. Now, for the variables, you want to say, what is the greatest number of x's I could divide all of these by? Could I divide all of these by x to the 4th? No, because there's only 3 x's here. Could I divide all of these by x to the 5th? I could this one, but I could not bring out 5 x's here. There's only 3. There's only 4 there. So the greatest number of x's I could pull out of each one of these terms is x to the 3rd. If I pulled out 3 x's, I'd have 1 left. If I pulled out 3 x's, I'd have them all. If I pulled out 3 x's, I would still have 2 left here. All right, so x to the 3rd is the greatest common factor. All right, and then what about the y's? What's the biggest number of y's I could pull out of all of these terms? Well, it's only 1. Even though this has 2, I couldn't pull out 2 y's here or here. So y to the first is the biggest group of y's I could pull out. So the greatest common factor of these 3 terms is 5x to the third y. That's the greatest common factor. Now I have a note right here on the bottom. It says sometimes the greatest common factor is 1. For example, in my Hawks, I had the numbers 18 and 77. And my first answer was there are no common factors. But that's technically not true because Hawks wanted me to say their greatest common factor is 1. So be careful when you do a problem like this in Hawks if they don't have a common factor that you see. All right, so here we have some more. So let's start with 99. So these are from my Hawks practice. So 99 is 1 and 99. 2 is not a factor because it's not even. What about 3? 3 would be 33. 3 times 33. 4, nope. 5, nope. 6, nope. 7, nope. 8. 9, yes. 9 times 11. And if you're not sure, just use your calculator. All right, now what about 18? So 18, 1 times 18 is 18. 2 and 9. 3 and 6. And is that it? Yeah, because 5 isn't, 4 isn't, and there's 6. So we're done with that one. All right, 54 is 1 and 54. It's even, so I know 2. 2 times what? 27. I know 3 is because 5 plus 4 is 9, and 9 is divisible by 3, which means 54 is divisible by 3. So in my calculator, I'm typing 54 divided by 3, and I get 18. Is 4, nope. Is 5, nope. Is 6, yep, 6 and 9. 6, 9. Did I get them all? If you're not sure, use your calculator. I think I got them all. Okay, so now what is the greatest common factor of 99, 18, and 54? Well, I see 2 18s. Let me double check. Is 99 divisible by 18? Nope. So 18 is not right, but 9 is the greatest common factor. I could divide all of these numbers by 9. So 9 is the greatest common factor of all 3 of those numbers. All right, let's look at 2, number 2. All right, so 3, there's only 2 factors of 3, which is 1 and 3. For 9, we have 1 and 9, and then 3 is a common factor, right? 3 times 3. So their greatest common factor is 3. So what about this x? Well, there's 4 x's here. So could I pull out 4 x's from both of these terms? No, I can't because this term has no x's. So even though I do see x to the 4th there, it's not a common factor. So the greatest common factor of those 2 terms is 3. Oops. All right, what about number 3? Well, 5 only has 2 factors, one in itself. Could I divide 35 by 5? Yes. Can I divide 10 by 5? Yes. So the biggest number I can divide all these by is 5. Well, it can't be more than 5 because this is the number 5. I couldn't divide that by 10, right? So 5, without even having to list these, I know that 5 is the greatest common factor as far as the number goes. Now let's look at the x's. Remember what we're trying to do. What's the greatest group of x's or y's we could pull out of all 3 of these terms? There's 1x, there's 1x, and there's 2 x's. How many x's could I pull out of all 3 of these terms? Well, I couldn't pull 2 out of here or here. So x to the first power is a common factor that they all have in common. And then I see y to the second and y to the second here, so I could pull out y to the second from both of these terms, but could I pull it out of this term? No, there isn't one. So this is the greatest common factor. They all have to have this factor in common, and that's the only one they all have in common. All right, now let's look at number 4. So the numbers are interesting. We have 3, 7, and 7. Well, can we pull a 3 out of 7? Can 7 be divided by 3? No. We'd get a crazy decimal. So they don't have a digit in common except for the number 1. All right, we'll put that, but we may not need it. But anyway, so 1 is their greatest common factor. That's a constant. Now let's look at their x's. What's the greatest number of x's they all have in common? 1x. I could pull this 1x out. I could pull 1x out of here, and I could pull out 1x out of that. So they only have 1x in common, all 3 of them. And then what about my y's? Do I have y's? Do they all 3 have y's? No, they don't. So the only thing I could pull out of all 3 of these terms, is 1x. Well, what is 1 times x? It's just x. So in a HOX, if you typed 1x, it'll tell you your answer is not simplified. All right, so now we're actually going to factor these polynomials, just like if I gave you let's say if I gave you a fraction like 5 over 15. Is that simplified? No, because I can make that number, both of those numbers smaller, but have an equivalent fraction by dividing both of these fractions by 5. So if I divide them both by 5, I'd get 1/3. Well, these two numbers are equivalent. They have the exact same value, but this is written in simplest form. Well, that's kind of what we're doing right here. We're looking at these. This is a binomial. We're looking at the binomial, and we want to know what is the greatest factor that both of these terms have in common. Well, we could list them all out if we wanted to, but I think we all know that 6 and 30 can both be divided by 6, right? 6 is the greatest common factor. So I'm going to pull out a 6 from both of those factors. Now I can't pull out the n because there's not one there. So now I am literally dividing each term by 6. So what's 6n divided by 6? Well, it's just n. What's 30 divided by 6? Well, it's 5. And I have just factored that polynomial by factoring out a 6. Now, what would happen if I distributed that 6? 6 times n is 6n, and 6 times 5 is 30. So these two are equivalent, just like my fractions over here. They have the same value, but this one's in simplest form. Well, same is true here. These are equivalent because I could turn this back into this, but this one's in the simplest form. All right, let's look at letter B. We have two different terms. What's the greatest factor they both have in common? What could I divide them both by? Well, there's 3 x's here. There's 1 x here. Couldn't I divide each of these terms by x? Yep, because if there's 3 there and I take 1 away, how many x's do I have left? X squared. Well, there's an x. What if I divided x by x? What's x divided by x? 1. What would I get if I used the distributive property? I'd get x to the 3rd times x, which is what I had when I started. All right, let's look at letter C. What can I divide both of those terms by? Well, I could divide 5 and 15 both by 5. And what's the greatest number of x's I could pull out of both of them? Well, the answer is 2 x's. So I'm going to pull out a 5x squared out of both of these terms. So what's 5 divided by 5? 1. What's x to the 3rd divided by x squared? Well, that would be 1x. There's 3 x's. I'm pulling out 2. I have 1x left. And I could write 1 times x, but I don't need to because 1 times x is just x. Now I have a subtraction problem or a subtraction sign, or I could think of it as negative 15 divided by 5. Well, negative 15 divided by 5 is negative 3, or I could just write minus 3. Now I pulled out both of those x's. So are there any left? Nope. I'm done. So if you use the distributive property, you would get 5x to the 3rd minus 15x squared. Minus 15x squared, which is what I have there. So I am done. All right, let's look at letter D. I want to know what's the greatest common factor all three of these terms have in common. Well, can I divide all three of those terms by 2? Well, I could divide 2 of them by 2, but what about 3? Is 3 divisible by 2? Nope. Could I pull out x's from all 3 terms? Well, not this one. So they don't have any greatest common factors. They only have 1. 1's the only thing I could divide everything by, and if I divided everything by 1, I get what I started with. So they have no other greatest common factors, or common factors at all. They have no common factors except for 1. All right, let's look at letter E. What could I divide 4, 2, and 6 by? I could divide them all by 2. Well, since 2 of these 2 factors have a negative, I'm going to go ahead and divide everything by -2. All right, what about how many A's do they all have in common? I could pull out 2 A's from this, I could pull out 2 A's from that, and I could pull out both of those A's. You want your first term to be positive. That's why I'm pulling out a -2. Uh-oh, I forgot my 2 A's. I could pull out a +2, and I'm going to do it so you can see that it would be the same answer. Equivalent. I'd have 2 equivalent answers, but anyway, I'm just showing you that you could write your answer either way, and it would be okay. All right, so what is -4 divided by -2? Well, a negative divided by a negative is +2. If I had 5 A's and I'm taking away 2 of them, I'd have 3 A's left. All right, a +2 divided by -2 is -1. I'm not going to write my 1 because if I have 3 A's, I take out 2, I still have 1 A left. And then finally, -6 divided by -2 is +3. And if I had 2 A's and I took them both away, I don't have any left. So I could get -2A to squared times, well, if I use the distributive property, this would be -4A to the 5th, which is what I started with. This would be +2A cubed, which is what I have here, and this would be -6A squared. Now, if I pulled out a +2, that would still work. All my signs would be the opposite, and that's fine. These are both equivalent. Normally, they want that first term to be positive inside your parentheses, but it doesn't matter. Now, if all of them were negative originally, you would definitely want to pull out a negative number. But on this one, you had 2 negatives and 1 positive. So either of these answers would be acceptable because they are equivalent. They are equivalent. And I don't have all negative numbers. You don't ever want to have all negative numbers. All right, now this one's a little interesting. So you need to probably make yourself a note on this type of problem. This one's a little different than the rest. If you notice, in these parentheses, they match exactly. So isn't 3x squared a factor of 5x plus 1? Because these are being multiplied together. Well, that means that 5x plus 1 is a factor of 3x squared. 5x plus 1 is also a factor of -2. So when these 2 parentheses match exactly, you're going to pull out what's in the parentheses and say this is a common factor of both of those terms. But if you pulled out both of these, if you pulled out what's in parentheses, what would you have left? 3x squared. And then if you pulled this out right here, what would you have left? -2. So that always works out that way. If you have 2 parentheses that match exactly, you're going to write one of them as a common factor. In other words, you're pulling this out of both of these first terms, and these you're going to put together as a common factor as well. Okay, and you'll have problems like this on your homework and also on Hawks. All right, so B looks exactly the same. These match exactly, right? That means I'm going to pull out 2x minus 3 from both of these terms. Well, what does that leave? It leaves a 7a And then if you look at this term, and I'm pulling out 2x minus 3, what am I left with? Well, isn't that just like multiplying by positive 1? So your other factor is 7a plus 1. You have to say what's left. So guys, if this was my paper, I would put a star on these and I would say, look, remember this. If these match exactly, you're going to use one of them as a common factor and put what's left as another common factor. You're just going to have to remember to do that. And that's what your notes are for. Make yourself a note. All right, now on these 3 type problems, you have 4 terms in each polynomial. So what you want to do is see if you can group them in a way that they share a common factor. So for example, look at letter A. If I put parentheses around here, do these 2 terms have a common factor? Yes, they both have an x. Now that leaves me these 2 terms. Do these 2 terms, can I divide both of these terms by a common factor? Yes, I could divide them both by 3. So I'm going to do that. I'm going to treat them as 2 separate problems for a second, and I'm going to put them back together. All right, so for these 2 binomials, I'm going to pull out an x. Well, this divided by x is y, and 5x divided by 5x divided by x is 5. Okay? Now, what do these have in common? They have a positive 3. So I'm going to include my sign, because if I put them together, it's going to look like a multiplication problem, because that's a positive 3. I'm pulling out a positive 3 from both of these. So 3y divided by 3 is y, and 15 divided by 3 is 5. Now this looks like those last 2 or 3 problems we just looked at. What's in parentheses match exactly. So one of my common factors is y plus 5. So if I pull y plus 5 out of this, what am I left with? X. If I pull y plus 5 out of this, what am I left with? Plus 3. And now when you stick it back together, make sure there's no sign here, because this is 2 factors. They should be multiplied. So your first step, you need a sign there. First step, you need a sign there. Second step, you should not have a sign between them, because they're factors, 2 common factors. All right, let's look at letter B. Letter B, I'm going to group these this way. Do these 2 terms have a common factor? Yeah, they both have an x, at least one x, right? So I'm going to pull out an x from both of them. Well, x squared divided by x equals x to the first. And then negative xy divided by x equals negative y. All right, let's look at our next 2 terms. What do these have in common? Well, I'm going to pull out that negative 5 right there. Negative 5. I'm going to divide both of my terms by negative 5. Negative 5x divided by negative 5 is positive x. And positive 5y divided by negative 5 is negative y. Now, look what's happened here. Now, these match exactly. If I pull out a positive 5, this would say plus 5, but then this would be negative x plus y. So I want to see if I can make these match exactly, and that's why I had to pull out a negative 5. So if you ever have a negative term right there, you're always going to pull out that negative sign with it. Now these match exactly. So one of my factors is x minus y. My second one, I'm sticking these together, x minus 5. I need a sign here for the first step. Second step, no sign, because these are 2 factors being multiplied together. All right, letter C. I'm going to use, this is factoring by grouping. So I am literally making groups. So look at my first 2 terms. What's their common factor? The answer is x. They both have an x in common. So if I have 2 x's, I pull out 1. I have 1 x left. A x, I'd pull out an x. I'm left with plus a. My next 2 terms, what do they have in common? A positive 3. Remember step 1, I need a sign right there. So what is 3x divided by 3? X. And then what is 3y divided by 3? Y. I think maybe this is a typo. I think that's supposed to be an A. I bet when they wrote these problems, they meant for this to be an A. So the way it's written, look right here. Do these match exactly? The answer is no. So you can't, these have no common factors. Except for 1. But if this is a typo, which I really think it is, if that was an A originally, and these now match exactly, I wish I'd caught that before I sent that to you guys. Sorry about that. Anyway, now if that were an A, our two factors would be x plus 3 times x plus A. That's only if this y was an A. All right, so anyway. All right, so these were some of the Hawks problems that I found when I was completing this section. So look at number 1. So the question is, what are my common factors? What do they both have in common? Well, the answer is 10. I can divide both of these terms by 10. What's 10 divided by 10? It's 1. It's not 0, it's 1. Can't have a blank there. What's 10x squared divided by 10? X squared. And that is the answer. Because if I use the distributive property, I go exactly back to this. That's what Hawks wants right there. All right, look at number 2. What did both of these terms have in common? Can I pull out 2 x's from both of them? No, but I can pull out 1. Can I pull out 2 y's from both of them? No, but I can pull out 1. So I had 2 x's, I pulled out 1. That means there's 1 x left. There was a y, I pulled it out. The only thing, did I pull out a 16 or a number? Nope. So 16 is part of what's left. There was an x, I pulled it out, it's gone. Where 1 divided by 1 is 1. I don't have to write 1 times 16 because 1 times 16 is 16. There were 2 y's, I pulled out 1. And so that's my answer. You want to always double check, just look back at it and say, okay, if I use the distributive property, would I get back this? And in this case, the answer is yes. All right, number 3. What can I divide all? Let's look at the numbers first. 7, -7, and 35. What could I divide all of those terms by? Well, I could divide them all by 7. How many x's could I pull out? The most number of x's from each of those terms? Well, only 1. I can't pull out 2 x's from either of these. And then what about how many y's? There's 3 y's, there's 1 y, there's 1 y. I could pull out 1 y from each of them. So what am I left with? 7 divided by 7 is 1. X divided by x is 1. 3 y's, I pull out 1. How many y's are left? 2. So 1 times y squared is y squared. Now, -7 divided by 7 is -1. So I'm going to write my negative sign. I might need a 1. I pulled out the 7, which is -1. I pulled out the x, which is 1, and y, I pulled that out. So what's left? It's not nothing, it's -1. Because just looking at that term divided by 7x squared, or excuse me, 7xy is equal to -1. All right, and then finally I have a positive being divided by a positive, so I know I have a plus. 35 divided by 7 is 5. X squared divided by x is x. Y divided by y is gone. I'm done. That is my final answer. And number 4 is factoring by grouping. So I'm going to circle, or I'm going to group 2 terms and 2 terms. All right, what do these have in common? They both have a C in common. CS divided by C is S. CW divided by C is W. What do these both have in common? The second step, you need a sign. They both have an X in them. So what do they both have? S, I'm pulling out an X, plus W. Now look at your 2 groups. Do they match exactly? Yes. So I write down that as one factor. What's in the parentheses and what's out of the parentheses becomes my other factor. All right, I gave you guys some problems and I gave you the answers. So I'm gonna go ahead and stop this at 30 minutes. That's long enough. Since you have the answers, hopefully you aren't having any problems with those. If you are, please send me an email or text me, and then I'll make another video for 7.2.